So hello everyone. Well, this is the work we've been carrying in the last 2 years and a half, and it's a communication protocol, low power wireless communication protocol that we think will be one of the key points in the next 5th generation wireless communications. So to put an example and to try that every one of you understand what's this, when you go to a football stadium and you try to call, if the stadium is full of people, you have contention. You cannot use the phone very well because when you try to access the network, there's a lot of collisions with other people trying to access the network. So the network in fact doesn't work. So, and this problem is present in Wi-Fi networks, in 3G networks, LTE networks, and in many low-power wireless networks. So what we did is we put a lot of effort on developing a technique. In fact, it's an algorithm that tries to solve this problem. So it's an algorithm that when there is not a lot of people trying to use the network, it just lets people access the medium. But when there's a lot of people or a lot of devices trying to use the wireless medium, it plays a game where nodes self-schedule in a distributed way, and they end up having a slot to transmit. They end up having the chances to access the medium and be able to communicate. So this work has been patented, and this is the first patent that the UOC group, Fundació Universitat Oberta, has done. And we think that this will have many impacts, and we are trying to put some effort in standardization committees such as 154F and -7, which is an ISO standardization group. And to evaluate that, we not only developed the algorithm, but we also developed hardware, and we implemented on hardware this technology, and we have some prototypes, and we are showing now these prototypes. In fact, I came from Germany, that I presented that to Siemens because they seemed very interested on the technology. So that's it. If you have any question, I will be in front of the poster sometime during today, and we can have a talk. Thank you.
Well, we will show you our presentation as a video. Video. Oh, maybe this is the okay.
Set of images better than set of words. Let's play.
Thank you for the introduction. I'm sorry I don't have a video because my daughter ate the video yesterday, so I have to make a standard presentation. Well, this is about the protection of digital media using data hiding techniques. First of all, I'd like to start with two simple questions. The first one, have you ever heard of any copyright infringement issue like that of Napster? Have you? Yeah. And what can we do from a technological point of view to avoid such situations? Well, a possible answer to this problem is the use of digital watermarking. And what is digital watermarking? Imagine that you have a digital work like this picture, then you can embed a secret message into it, for example, a copyright notice, and what you get is a marked object where the hidden message is a watermark that is spread all over the content. In this case, the mark is visible, but in most typical situations, it wouldn't be perceptible. So, what are the applications of this kind of technology? There are many, but the more relevant ones are the following. It can be used for broadcast monitoring. For example, to obtain automatic reports of how many times a given commercial is broadcast on a TV or on a radio station. It can also be used to embed a mark with the owner identification of the content, or even to prove that ownership in case of a copyright infringement issue in court. It can also be used for fingerprinting. This means embedding different watermarks for different buyers of the same content. Also for content authentication to detect forgeries or fake copies of the content. Also for copy control. You can determine how many times a content can be copied from the original. You can use it to control devices like a DVD player, or also for secret communications. What are the properties that a digital watermarking method must have? The first one is imperceptibility. Should the mark be visible or not? Second one is capacity. How much information can I embed in the digital content? Then I will have low or high capacity. Also robustness. Is the mark easy or difficult to remove? And finally, security. Can an attacker embed, modify, or break the watermark? Thank you.
Good morning, everyone. I'm Georgia Sellu, and I'm participating as a researcher in Crossfire project in York. And today I'm here to talk about a technique called network virtualization applied in 5G cellular networks. Okay, actually, have you ever heard, all of us, the words 3G, 4G, 5G networks and how they are going to change our lives, how they are affecting our lives? Okay. Let's go and see the trend of the data traffic in our phones. Okay, according to a recently public report by Cisco, we can see that the last 5 years the mobile data traffic has grew, and besides that, an imminent growth is expected for up to the 7 years that follow. But which are the trends that actually motivate us to study this kind of technologies? We're having more users interested in specific kind of services. Also, we're having more mobile connections, and as well as faster mobile speeds due to specific needs like mobile video that we actually use every day. And here we come as. We are trying to find, develop, and test algorithms that can use the same infrastructure, so having the same actual physical infrastructure and split it in different ways, and can be used by different users that want to have access in internet services. And finally, I would like to talk about the potential benefits that this situation has. It can help in the rollout of new services, and actually by using the same infrastructure we can save energy and reuse same hardware devices by applying software instead of using the actual hardware device. So, this is all. And if you have any other question on everything, we can take advantage of the poster session. Thank you.
Hello, my name is Jordi Casas, and I present our work with Jordi Herrera and Vicent Torra on privacy preserving on social networks. Our scenario is about data releasing to third parties. In this scenario, we have to preserve the privacy of users who appears in the data. Otherwise, an attacker can infer the identity of some users, linking the released data with his real profile. In this example, we can see in the first figure a social network with real names and key identifiers. In the second figure, we can see the same network without the real names, but an attacker can use the structural information to re-identify some nodes. For example, in figure 3, we can see that user Dan have a unique one neighborhood structure, so we can re-identify it in anonymized data. So privacy preserving on anonymized methods add noise in the data to hinder the re-identification process. There are three main classes which we use is network modification, which add noise, adding vertices or edges to the data. And there are two main kinds, randomization or canonymity model. We apply the canonymity model. And in order to quantify the data utility or information loss, we use several abstractal and spectral properties. And also we compute the clustering and commutation algorithms to avoid the data utility. And we also use information flow to improve the data utility. Our first approach is use evolutionary algorithms for graph anonymization. And what we do is we can anonymize the degree sequence using evolutionary algorithms, and then we reconstruct the graph structure using the canonymized degree sequence. But this one is only we achieve good results on only small networks. So our second approach uses univariate microaggregation to anonymize the category sequence, which allow us to anonymize this first part in a polynomial time, and then we apply this 3H modification, the switch, removal, and addition, to reconstruct the original graph. Here we can see the medium or large network. For example, the third one, Yahoo, is a network about 2 million nodes. And thank you.
Well, hello, thank you for coming. Today I want to invite you to come to see our poster. It's a collaboration with some colleagues and supervisors from Pompeu Fabra University and from my thesis supervisors here in UOC. The idea of this kind of technology is to reuse well-known algorithms in the literature, because the distribution, transportation, and logistic problems have been studied for more than 50 years now, and we propose to take this, to reuse this type of components, apply some distribution, probability distribution steps inside of this process, and then apply it to real context. So this poster actually is about a real case applied here for Bonaria supermarket with more than 400 supermarkets in Spain. Actually, we applying this technology, we save more than 30,000 euros in 25 days. Applying this technology and more than 60,000 kilometers. So for this type of NP-hard problems, we can develop. We have designed and developed, implement this type of randomized heuristic algorithms. So if you have any doubts or any questions, you can approach the poster and I can help you. Thank you.
Hello, good morning. My name is Amna. Today I am going to present secure and anonymous multimedia content distribution in peer-to-peer networks done under supervision of my supervisors, Helena Repa, David Matthias. Mainly there are 4 objectives involved during the design of this process. The first objective was to provide security to the copyright holders and the merchants, and the privacy to the end users. Second objective is the efficient distribution of large size file over P2P with reduced computation costs. Third was to provide conditional privacy to the buyers, and the fourth was to provide dispute resolution mechanism that will protect the innocent users from the malicious merchant. The main model, the first step of the model involves the content provider, and it generates fingerprints. It uses TADOS collision-resistant fingerprint codes and DWG that provides the approximate coefficients and detailed coefficients. The approximate coefficients are used to constitute the base file, and the detailed coefficients are used to constitute the supplementary file. The second step is because the TADOS fingerprint codes are generated using a secret vector to protect the buyers from the malicious merchant. The monitor is used to exchange the encrypted hash of the secret vector. The base file is transferred from the merchant directly to the peer, and the supplementary file is transferred from the super peers to the peers in a P2P fashion. And once a piloted copy is found, the merchant uses data tracing algorithm using the TADOS data tracing algorithm to identify the set of polluters. And the judge is there to arbitrate between accused buyer and the merchant. We use 2 files, the audio files and the video files as well, and that are designed. The base file is considerably reduced, and with better transparency values for both the audio and video. Thank you.
Basically, what we are developing here together with Professor Scott Grassman and Marcus Rapp is a new methodology to deal with complex systems. All of us work with complex systems, very complex systems, and at the beginning we tried to solve these complex systems or processes by using exact methods. Then we understood that exact methods are not enough, so we moved to meta-heuristics. And meta-heuristics are fine, but they forget something which is very important in real life, and this is randomness, stochasticity, because real life is not deterministic. It is stochastic. You have a lot of randomness in real life. So what we notice is that, okay, do we have some tool in science that can help us to solve this, to deal with this stochasticity? And in fact, we have it. It's called simulation. So why not to combine simulation with meta-heuristics, and then to provide a very powerful tool to solve very complex problems? And the tool is called Symmeristics. So basically, this is the role of Symmeristics. It's a tool for helping us to solve very complex stochastic optimization problems, even those which are NP hard. And you can find applications, and in fact we are working in applications to very different fields, basically in logistics and transportation, because this is the field we feel more close to. But we are working also in applications to aeronautics or telecommunication systems. So I think it's a very general tool that can be applied almost to an unlimited number of situations. And just to conclude, so I wanted to introduce this new methodology, which is called Symmeristics. It's the combination of simulation with meta-heuristics, and it's very powerful because you can deal also with the stochasticity inherent in the complex systems that we have today in smart cities, in smart processes, and things like that. So the main point is that we expect this tool to be a good instrument for decision makers in order to generate smarter and greener solutions. And that's all. Thank you.
My name is David Sanchez. I am a member of the Scene Understanding and Artificial Intelligence Lab. And today I am presenting you one of our research lines, which is called Emotional Network Computation using Facial Expression Analysis. And what do? Basically, our aim is to build methods and algorithms to classify, to recognize, to track, and finally to describe facial expressions. And how do we do it? Given an image or a video, what we first do is localizing the face and then also localizing those points you see in red that are the interesting points of the face, the points that tell us something about what is happening in that face. And with that, we can build higher level descriptors that allow us to detect complex emotions based upon atomic and isolated movements. What we do really detect is those tiny atomic movements of our face. We can detect emotions because emotions are nothing more than linear combinations of these atomic movements. For instance, surprise could be the combination of outward brow riser plus left corner puller. On the other hand, sadness could be represented by inner brow rising and left corner depressor. Can this technology be applied in real life? Of course, yes. For instance, 3 examples: human-computer interaction. This technology can make machines or computer programs being able to modify, to change, or to adapt their behavior according to your mood. And your mood is expressed in a very high degree with your face expression. Another example, with this technology, we can detect and we can treat some mental diseases, for instance, autism. And finally, we are at UOC, an online university, and this technology can improve, has a lot the e-learning experience. Imagine you professors that I tell you, hey, I have this piece of software that can tell you, for instance, in the page 7 of the material you have submitted, all of your students express, for instance, frustration. Or on the other hand, on that particular course, on page 2, 90% of the students express satisfaction of confidence when they see your fancy diagram you have included in it. Isn't it useful for you? If it is, please stop by our poster and we will explain you a little bit more in detail what we do. And if you want, you can participate in a demo with your own faces. So thank you very much.
Hi, good morning everyone, and thanks for being here. I'm here with my thesis director, Joan Almedo, to present our work. Well, you can see forensic imaging and analysis of iPads and iPhones. So as you know, smartphones have grown rapidly in the last decade. So now in our pockets, one here, another one here, we are wearing devices full of personal data. Okay. Being a relatively new operating system and applications, it's a good ground for researching in terms of what data can be extracted from the device and what data can actually be inferred after extracting such data, okay? So as I say, we have 2 focuses. Number 1, extracting data, and number 2, analyzing this data to see what, for instance, user activity can we infer from this. Please. Okay. So, iOS is a closed operating system, which means that we'll not run any software that we want, just signed applications, and even those run with limited privileges, run sandboxed. Okay, so we leverage the process of jailbreaking to be able to run custom code with root privileges, which gives us a much better view of what's going on inside the device. In terms of forensic imaging, we found that using a cheap iPad accessory, the camera connection kit, which you can see here, the iPad can be attached to a hard drive and can extract data directly to the hard drive, being about 30 times faster than other similar methods based on Wi-Fi transmission. On the other hand, when analyzing the retrieved data, we found that the AirPrint feature for printing wirelessly leaves a trace in the device that allows us to recover exactly the contents of those documents that have been sent to the printer. Printing is not the most obvious vector for all of us. I mean, we transfer information in other ways much more frequently, but we found this to be an interesting feature because it was quite recent, and as far as we know, no one else has reached into it. In the future, we would like to focus on other new features of the iOS operating system, such as iCloud synchronization, and especially AirDrop for sharing files between nearby devices using both Bluetooth and Wi-Fi. If you have any questions, you can drop by our poster. Thank you everyone for being here.
Okay, thank you for the introduction. So this work is an application that uses analysis of nonverbal communication in victim offender mediations and using multiple data modalities. This is an example of our conversational setting that we require when we acquire the data from the different viewpoints of the camera. These are the regions that we acquire the data from the different points of Catalonia. And we also can see the illustrations of the different cities of justice, because this work is done in collaboration with the Department of Justice with the government of Catalonia. And so this is the framework of the system. First, we perform a multimodal feature extraction using the different data modalities, the audio, RGB, and the depth data. Then we extract the behavioral traits from the different subjects that participate in the conversation. And finally, we use these features to learn a classification problem in order to predict the agreement on the different subjects that participate. Okay, so within the multimodal feature extraction module, we perform a speech diarization process from the audio information for the different subjects. Then we perform a user segmentation using the depth modality, and a detection for the different regions of the body. The face, the hand, and the upper body regions. We have here the different illustrations. And from these low-level features, we extract the behavioral indicators using these 4 blocks: codification of target cases, agitation estimation. We identify the poses of the people, and we detect the speech turns and interruptions. Finally, we use different classification approaches that are able to predict the agreement in this conversation, achieving an accuracy of 75% given by neural networks, which is classification approaches. And these results shows the correlation between the opinion of the experts, in this case the mediators. So if you want to know more information about this work, you feel free to visit me in the poster session. Thank you very much.